This video is on phenols, thiols, and ethers. Starting with phenols. Phenol is an aromatic ring with a hydroxyl group as a substituent. Recall that a hydroxyl group is an O bonded to an H. These are different functionally than an alcohol or an aromatic hydrocarbon. So below you will see examples of phenols. You have your aromatic ring with an OH attached to it. The same everywhere. This is new for us, this circle. That just means that there are alternating double and single bonds taking place with delocalized electrons happening there. So that just means the same thing as you see previous. In nature, briefly, foods such as vanilla add flavor and aroma to foods. These are phenols. Antioxidants, vitamin E captures damaging free radicals, which are very reactive and have a single non-bonding electron. So here are your two examples. Here is your ring with your OH, and again your ring, aromatic ring with your OH. There's the same thing. There's your vitamin E complex. And all of this over here are your carbons and hydrogens. All right, naming phenols. We use the same rules that we used for aromatic hydrocarbons, except we are replacing the word benzene with phenol. Carbon bonded to the hydroxyl group is the first carbon. So you always want to start with that OH group. So here you can see we have our aromatic compound here. And then we have a bond to our OH. That's how we know it's a phenol. And we have a branch here off the third carbon. We start one here. And that is an ethyl branch. So it's 3-ethyl phenol. Notice we counted the way we did. We didn't go 1, 2, 3, 4, 5, because that would have had to be a 5. We always want the smaller number possible. So that's why it's a 3 there. So same thing as we did with benzene, except we're just replacing the word now. Write the skeletal line structure for the following compounds. So A is methylbenzene. So I know benzene has alternating single and double bonds, and then it just wants a methyl group, doesn't matter where, so I'm just going to draw it like that. B says 2-methylphenol, so I'm still drawing my aromatic ring, but since it's a phenol, I need an OH group off of it, doesn't matter where, and now that's my first carbon, so this is number 1. So I'll just say number 2 is here, and I just need a methyl off of that. And that is my answer. Thiols. Thiols are compounds containing SH groups bonded to other carbons or aromatic carbons. So the SH group is often referred to as a sulfhydryl group. So this is the first time we're really seeing S being used, sulfur. So you can look to the right here. Here is your SH, and it is bonded to a carbon. Here is your SH, bonded to a carbon. So that's how we know that it is a thiol. Naming simple thiols. So they are named as your alkane, whatever it is, methane, ethane, propane, and then the word thiol at the end. So if we have 1 C, it's methane thiol. If we have 2 C's, ethane thiol, and you can see down here. So your SH group, that's how we're alerted to it being a thiol, and then since it's only a CH3, it's methane. Again, here is our SH, so it's a thiol. Since there's 2 C's, it's ethane. Thiols with 3 carbon atoms. So we can see up here, I didn't go over it, but I will now. It says larger thiols require locator numbers for the group. Larger means 3 or more carbon atoms. So in these two, for methane and ethane, we don't need a locator. Here, we do need a locator. So you can see here, we have our 3 carbon atoms. And then you can see our thiol indicator here. So 3 is propane, so propane thiol. And then we need, since it's off the first carbon, we need this 1 here. So 3 or more, you need a locator number. Okay, here we have our SH, so there's our thiol. We have 3 carbons, so that's how I know it's propane. And then it looks like the thiol is off the second carbon, so that's why it's 2 propane thiol. So for thiols, we are thinking SH. In the real world, they have strong odors, so cheddar cheese, garlic, it looks like onions with 1 propane thiol causes your eyes to water. Skunk spray contains a thiol. Looks like ethane thiol is added to natural gas, so leaks can be detected. So that's pretty cool. And here are some structures for them. Here's your SH bonded to a carbon. SH bonded to a carbon. Okay, name these simple thiols. I would encourage you to pause the video. So there is my thiol group. I have 3 carbons, so I know that this is a propane thiol. And it looks like it's off the second carbon, so this is 2 propane thiol. Okay, to the right here, it gave me the condensed structure. So how many carbons do I have? I have 1 carbon, and then I have 3 of these. So I have 1 carbon, 2, 3, 4, 5 carbons. So 5 carbons is pentane. Here's my thiol. And then where is it attached to? I'd want to start from the right-hand side here. So this would be my first carbon. This would be carbon 2, 3, 4, and that would be 5. So it's 1 pentane thiol. I would not want to say 5 pentane thiol. And down here, this is my main chain of carbons. It looks like it's closer to the right, so I would start labeling from here. And there's 7 of them, so that's heptane thiol, and it's off the 3rd carbon. And the last one, ethers. So the ether functional group is when an oxygen atom has single bonds to 2 carbon atoms. So you can see it's ROR, R being the rest of the atom. But it's going to be either, a carbon chain, a straight chain, it's going to be a ring, or an aromatic group. So here are your ethers. Locate your carbon. It's bonded to 2 C's. Below, locate your carbon. It's bonded to 2 C's. So that is your giveaway that it is an ether. Ethers are used in anesthetics, so to put patients to sleep. O bonded to C's, O bonded to C's, O bonded to C's. So here is an example where there is an alcohol present and an ether present. And look at the difference. Your alcohols, recall, that is when the O is bonded to an H. That's our dead giveaway. And then 1C. Your ethers, it is bonded to 2Cs. So just keep those different, keep those separated. And then your thiols, of course, that is your SH. So I would pause the video here and try to do this before I give you the answers. So we have to say if these are alcohols, phenols, thiols, or ethers. So in A, I see an OH here. It's not an aromatic ring or anything, so it's not going to be a phenol. So that is just an alcohol. Remember, phenol is a ring with an OH. B, I have an O bonded to 2Cs, so that is going to be my ether. C, I have my OH, so maybe an alcohol, but it's bonded to this ring here, so that is my giveaway that this is a phenol. And D, I have my O bonded to 2Cs, so again, that is an ether. So we do not have any thiols here. Recalling thiols are your SH.